Hey guys, in today's video we are going to solve LeetCode 435, that is non-overlapping intervals. So this is a medium level question, but honestly speaking this is not that complicated one, because once I'll explain you how we can approach the solution step by step, you will be able to understand that this question is not that hard, but it's a really nice question. So let's see what we are given in this question. So we are given an intervals array in this question, and we have to eliminate some of the intervals, or we have to remove some of the intervals from this array in order to make rest of the intervals as non-overlapping. So let's try to understand this question using this example. So as we can see that these are the intervals, and we need to eliminate the one or all the intervals which are overlapping. So how we can understand that which interval is overlapping? So let's try to visualize these intervals on number line so that we can see the overlappings easily. So this will be 0, this will be 1, this will be 2, this will be 3, and let's name it 4. So our first interval is 2 to 3. So fine, I mark this as 2 to 3. I block this slot. So this is one interval, and we can see there is no overlapping interval for this one right now because this is our first interval. So let's check out 3 to 4. So we can see the 3 to 4 interval starts from here and goes till 4. So these two intervals are also not overlapping because 3 is the ending of the previous interval and the starting of the next interval. This is one thing that we realized after plotting these two intervals, right? That we are checking the ending of the previous interval, that is the previous ending, and the current start point, that is CS. And what we are checking, we check that 3 is equivalent to 3, that is previous endpoint should be less than or equivalent to the current start, right? We realized this thing after plotting these two intervals, because if this value 3 4 interval, the second interval will be consisting of values such as 2 to 5, then we won't be able to plot this interval, right? Because this will be overlapping. So this was the reason that we plotted this interval, and we realized that this is not overlapping. So this is one thing. Now let's go to another interval, that is 1 and 2. So if I'm going to check the same condition, this one, that is PE less than or equivalent to CS, for this interval 1 and 2, then I can see that the previous ending was 4, but the current ending is 1, 2. And I can see that this condition is not satisfied. So if I'm only going to check these interval on the basis of this condition, my answer will be wrong, right? Because if I'm going to plot this interval on my number line, I can clearly see that this is a non-overlapping interval. But when I'm trying to check this interval using this condition, I'm getting false, which is not right. So I realized one more thing, that not only the ending of the previous interval is an important thing, or the starting of the current interval is the important thing, but also the series of these interval matters. Because our number line is in sorted order, that's why we are able to plot these intervals in right manner. That's why we realized after this point that we need to sort the intervals as well. Then only we will be able to apply this condition and get our answer, right? So let's try to firstly sort our array, and then we'll see that we are getting our expected result or not, which most probably we are going to get, because this condition is absolutely right. So let's try to visualize this condition with sorted array. So if I'm going to sort this array, what will be the values? So firstly 1 and 2 will come, and as we already saw in the previous method that we were following, the major focus is on the previous ending intervals. So what is previous ending interval? It is an ending interval that we are just storing, so that we can check it with the next upcoming interval whether they are overlapping or not. So we will be sorting our array on the basis of this interval only, second one. So according to that, the first value will be 1, 2, the second value will be 2, 3, then it will be 2, 4 and 3, 4. When the ending is similar in two values like 2, 4 and 3, 4, we will be checking for the first value. And for the first value, 2 is lesser than 3. That's why 2, 4 comes first and 3, 4 comes after that. So after this, again I'm going to apply the same condition, right? For 1 and 2, I will take 1 and 2 on my number line. Now our number line is also sorted and our array is also sorted. So we will be able to check the overlapping easily. So 1 and 2 will be this one. We block this slot. Then 2 and 3. So 2 and 3 is also blocked and this is also not overlapping. Then it comes 2 and 4. But now 2 and 4, if I'm going to check that previous condition, that is PE should be less than or equivalent to CS, that is the previous pointer should be less than or equivalent to the current start, I can see that this is not true. And also when I'm going to plot this on my number line, this is overlapping with this 2, 3 interval, right? So I am not going to take this interval and I am going to completely eliminate it. So my answer for elimination will be increased by 1, right? Elimination will be +1 right now. Then I'm going to check the next interval, that is 3 and 4. Now for 3 and 4, what I'll be checking? The previous ending pointer, which is still 2 and 3 because we hadn't plotted this 2, 4 interval. So for this, I can again check the condition and this condition is satisfied. And also when I'm going to plot it on my number line, this is true. So what we realized is, firstly, we need to sort the intervals. Secondly, we have to check this condition whether the previous interval's ending is less than or equivalent to the current start. And if that's true, then only we'll consider that the interval is not overlapping and we will proceed. Else, we will simply consider that interval to be removed. So this is the whole solution. But this is a greedy method, right? We are trying to solve this question using greedy method. Is there any other method with which we can solve this question? Let's see. So if I'm going to solve this question using some other method, suppose I'm going to take this interval. I'll take this interval and then I'll check rest all the intervals whether these are overlapping or not using the same condition, that is PE less than equivalent to CS. Then what I'll be doing, I'll be looping through this array twice. So my time complexity for that method will be big O of n square. This is one method. What can be another approach is, I'll be taking every interval and I'll be checking whether they are overlapping or not. And in this manner, I'll be making two decisions, right? I'll be checking two conditions for every interval. So that will be, I'll be checking two conditions for all the n intervals. So the time complexity will be big O of 2 to the power n. This is also a huge time complexity in comparison to the one that we saw using greedy method, because greedy method is taking how much time? Let's calculate that. So firstly, we are sorting our array. So that will take big O of n log n, right? And after that, I'm traversing through that sorted array and checking whether the value is overlapping or not. So it will take big O of n time. So this one is the dominating one. So the overall time complexity of the greedy method will be big O of n log n, which is way better than big O of n square and 2 to the power n, right? That's why we are using greedy method over these two methods. And the space complexity of this greedy method can be considered as big O of n. Why? Because we are using sort function, and in Python the function itself uses tim sort, and tim sort takes big O of n base in worst case, big O of n in worst case. That's why we are considering that our space complexity is big O of n. But if you are going to check in Java or C++, so the time complexity will be around log n, because in these two languages the sort function is dependent on quicksort, uses quicksort in these two languages. That's why the complexity will be log n. But we are going to code the solution in Python. That's why we are taking as big O of n is time complex. So now let's code this solution. So I already wrote the algorithm because that will make easier for us to code the solution. So as our algorithm says, like firstly sort the intervals array. So let's just sort it by writing intervals dot sort. What we discussed in the explanation, that we will be using the second value, that is the ending of all the intervals, right? So this will be our sorting. So this is how we are going to sort our array. And after this, what we are saying, create a default pointer for PE for storing end of previous intervals, right? So let's create a PE and initialized as minus infinity. Then create a result variable which will be having our answer, like how many intervals we are going to eliminate. This will be the one which will keep all the record. Now let's loop through the whole intervals array. Now what I'm saying, check if the start is greater than or equivalent to the previous ending. In this case, what I'm saying, just update our previous ending, and if this is not the case, then update my result, because this means that we hadn't included that in, so that's why we will be increasing our resultant pointer. And after getting out of this loop, simply return result. That's all. This is the whole function. Let's try to run this whole function. I again did a typo. Let's try to submit this. Okay, we can clearly see that this is getting submitted, passing all the test cases, and this was the whole solution for this question. I hope this video was helpful for you all. So if you really find this video helpful, you can like this video, subscribe my channel, and I will soon come up with few more videos. Till then, keep watching, and thanks for watching.